So my name is Tatiana Erekhinskaya. I work at Lymba. It's a Dallas-based NLP and semantic company. I do NLP, the whole NLP, and nothing but NLP for more than 10 years. I started back in Russia, where it was not popular at all. I even have experience with rule-based NLP, because even data for machine learning was not available. So I kind of know the whole history by hand. And yes, basically today I would like to a little bit provoke you, saying that deep learning is not going to work. Well, we use it as a complementary tool, but I want you kind of to see this another side. Obviously, it's all based on my experience, but I just want to share considerations that you might find practical if you hit some real problems similar to this. So to start with, I will talk about use cases that we work on the semantic approach that we use, and then I will ask my questions about deep learning and share what we learned with kind of general working with customers on multiple NLP projects. Oh, one thing I wanted to do, how many of you do NLP, ontology? Okay, that's, yeah, okay. And how many of you didn't go further than NLTK, maybe a little bit of Coursera class? So, okay, so mostly are professionals kind of here. Okay, we'll see. So that's what company does overall. So we take text in any format. We do a lot of pre-processing as well to get actually the text from documents, from contracts, and so on. And then we extract knowledge in different format, and then we use this knowledge to drive different applications. And so we do basically all kinds of things. And recently it feels like summarization is something that companies are interested about. So it historically we do semantic parsing, like really deep analysis and question answering. So we are a commercial company, so people come to us with their use cases. And last year we saw the same summarization projects coming again and again in different domains. So this is something that I want to share. So this is the first use case. See how good you could be a marketologist, because for me it was a real surprise. So the company doing investment services analytics based in London. They want to be smart. They want to look only not on financial documents of the company, but to know how green the company is. So is it going to be sustainable or not? And what they did, they asked to extract information about the company from court proceedings. Because everything, all dirty details show up in the court. So that was a use case. I wouldn't be able to invent it, really. Like, I was very much surprised that somebody needs this combination of this data and this resource, this information. So another use case is national security agencies. So we work a lot with government, and basically they want to know in what countries, on what domains, and who works, who are the key leaders of opinions, how advanced technology is, especially if it is something that has issues with security. So the source was research publications, and it's basically extraction of metadata plus extraction of the content of the research, basically. So we created profiles about researchers. Again, so before NLP, it was like to annotate one researcher, to create profile for one researcher, it took half a year of somebody PhD level, because it's a research paper, so you need to know what's inside, and to extract all this manually. And I mean, you can imagine, so with NLP, it's basically from the whole collection, we extract information about everybody. So another example, so far with the company profile, person profile, this is I'm sorry, okay, so it's a wrong title. This was proposal profile. So again, government agency issue call for proposals, and then they get a pool. Some of them are well written, some of them are not so well written, some of them become funded, some of them rejected. But after that, there is a new call for proposals. And the agency wanted to see what is the trend. So what people are interested about to make a more informed decision about what should be the next call. So again, so the information they needed was a kind of summary of proposal. And okay, so this is about medical domain. We work with the Center of Medicare and Medicaid, who try to come up with quality measures for healthcare, basically. So basically, when you come to doctor with a high blood pressure, the doctor says, okay, here is the pills. After some time, you have a different blood pressure. Is it good enough? So the doctor did a good job or not? So it's actually, I still don't understand exactly how they do it, but for us the task was, here is PubMed publications, and they want to know what was the clinical trial with all demography and all characteristics of patients, and what was the intervention, and what was the outcome. And then they do something else on top of it to come up with the actual, okay, can you hear me? Okay, because I sometimes get, okay. So basically they needed to summarize information about clinical trial. And here's my pro bono project with a PhD student from management school, just kind of to show you how deep it goes nowadays. So he wanted basically a systematic review publication. When he says, okay, here's my pool of publications about big data, and he only wants to collect information, which company used big data, what the industry, what was the task, what was the outcome. So in a way, it's even similar to the, clinical trials, because it's a problem with give a solution, and there is some outcome. So this in short, what we see again and again. And so this is my kind of favorite use case, because it's sort of recursive. So it's big data applied to big data. And basically this is the common ground. So there is a lot of text, and big text for humans is much smaller than big data for machine. So we get lost very easily. And if only 5% of the text is useful, then basically the whole text is very boring and nobody wants to read it. So this is what we normally do. So we take old-fashioned semantic approach. So we sit with the customer, we define template slots, what they actually want to extract, and then we collect annotations. So this is where we get back when we talk about deep learning. And so basically then we train NLP and semantic tools to populate these slots. Some important thing here is to balance recall and precision, because depending on what customer prefers. Either they prefer a strong signal and they're okay to leave something in the data and never see it. Well, then it's one story. So it actually really depends on the customer. So this is something that we also need to be able to tune in our system. And so for many tasks, there is still human in the loop, because today somebody said a good phrase about it. We take people away from copy-paste business. So we do the rough information with extraction. We don't do like summarization on top. We don't generate text on top of it, like paraphrasing, because it can be really tricky and you need to know what you're talking about. So we still allow human in the loop, but so it's for review and maybe for kind of generalization, some sort. But we also provide tools for them. So it's not a black box that you cannot interact with. It's always some UI that supports users through the process. So here is basically what is a template slot. And it can be either sentence, either named entity. It can be classification label, when we just first extract some fragment and then we say, is it use case about, is the result just sensing, or is it transforming the company? So we classify on top of relevant fragments for that. And another thing is semantic relations, like in the case with medical domain. So the patient is undergoing some treatment. So, yeah, I wanted just to show before you fall asleep. Here is this. So here is a domain model for medical. It's actually for nursing. So, okay, let me just, so the size of the problem. So here is a patient, and then it gets mapped to all kinds of meta-thesaurus tools, concepts. So basically we know that parent is an organism, and then we have patient can be part of population in some clinical trial, and then all health status goes here, and it's kind of hierarchical. And so we basically train NLP to extract instances of the concepts and the relations. So basically, if you look on NLP pipeline, it's pretty standard. So it has sentence boundaries, tokenizer, named entity recognizer, word sense distribution there, dependency parsing, and the last step is semantic parsing. This is something that it's our secret sauce, kind of. So let me jump again here. So this is a piece of text from a nursing book, and representations that we extract for this. So first of all, we extract concepts and the relation between concepts. That's what we used to do till recently. So with, for example, say that 250, so it has unit this measurement. And recently we started to say, okay, phrases, we need also phrases around, so we can do relations between, between graphs, basically. And we do it all in RDF so that we can do inference. Here's what I need to check. How many of you heard about RDF? Okay, here is yeah, so it feels like there is a disconnect between an NLP community and semantics community, so we are kind of combining these two things together. So we say that, okay, here is ontology. We prefer small ontologies so that we can train NLP to extract the instances, and then we do inference on top. So, like again, for medical example, for let's say we know that under some medical condition you are not recommended to exercise, and from somewhere like WordNet we can say that jogging is an exercise. So from here we get inference that with this medical condition you shouldn't do jogging. So this is kind of something that has been around since 80s. So it's basically a subset of first-order logic that is supported by RDF stores. Yeah, so this is another model that we use for CMS. And again, it goes deeper. Oh, okay. So how many of you have never heard the word ontology? Okay. Then just enjoy. So let's say that you are a 6-year-old kid, and you are going through exam to get to the school. So here the teacher shows you 4 words and says, so pick one that doesn't belong to the list. Are you, okay, so remember your answer. So the teacher expects the kid to pick up wolf, because wolf is wild, scary, and the rest are domestic. And the kid, this was a real story, so I know the kid actually said cow, because cow is herbivores, and the rest are carnivores. And he was able to explain this. So to me, this is something that taxonomy and ontology can help us to do. Something that, for some reason, right now, we are throwing all this knowledge from graphs away with deep learning. That is kind of feels sad for me. So, and the way we go around is, so let's say we have a text, then we extract, so if you have a definition, or any explanation, we just convert it into a semantic graph. So if you see that wolf dash a wild carnivorous mammal of the dog family, then we can extract either relation by our semantic parsing and get ontology and do inference on top. Yeah, this is, okay. Something that we did mistakes. So again, getting back to template filling. So this is normally not very high-paid projects, and we need to make them reasonably fast and reasonably well. So what one of the problems we saw is ambiguous slots. A good example would be drivers for proposals. We really needed to ask back, like, what do you mean drivers? Is it participants? Is it some causes? And what do you mean, basically? What do you want to extract? Another thing, even if definition is clear, it's very possible that the gold standard will be highly subjective. And well, so basically, to get a labeled data correctly is a pain, mostly because customer needs to be involved, and they're not very cooperative, and they don't know how. That they feel like, okay, we just label somehow. They normally give it to somebody who doesn't care or doesn't know enough. So somebody whose time is not so precious. And it brings back the results, basically, according to the standard. So subjective slots is something that we saw several times, and that's why we really ask them to have several people to look through the data. and better if they don't communicate to each other. So like they do it in separation, and then they look on the overall result, fight, and we take the winner, basically. Yeah, and this is also something about sampling for annotation. We will never again allow customers to sample the data for us, because they're very much biased. Like, for example, with the case for proposals, what they did, they annotated funded proposals. Because, well, they're nicely written, they thought about them many times. It was a piece of cake for them to annotate. And it worked nicely on other funded proposals. But when we apply the same system on not funded, it's a different ball game. So it was really hard to extract. So basically, we needed to do a second iteration of annotation to capture something that is not so well written. This is another trick. I don't know why, but all customers want 90% of quality. They don't know actually what is precision, what is recall. They cannot compute accuracy. They even don't realize that for many NLP tasks, 90% is like really, really high. They just want 90%. So the way around that for us was, okay, we give you 90% of time reduction, of manual effort. So this is something that kind of ran away, sort of. Okay, so this is my favorite part. I actually thought that I need to bring some tomatoes so that you can throw at me. But I want you to kind of stop sleeping and debate with me, and I hope to learn something from this as well. So, well, very often we see that it's not enough of labeled data. It's either sensitive and confidential, so we cannot put it on Mechanical Turk, or we cannot give it to some low-paid people. Or it can be PhD hard, so you basically so much in some biological or nanotechnology domain that you really need a PhD person to annotate, so it's just too expensive. Or it might be that it doesn't exist. For example, if it is some commands to some natural language interface, then there is no corpus, there is nobody created the system yet. So there is no logs from which we can take at least unlabeled data. So the data doesn't exist at all. So to me, it's a little bit like deep learning versus traditional NLP. It's like a trade-off between writing rules. Well, if it's easier to write a rule, well, let's write a rule and just, that's it, get our money and everybody happy. Then, okay, so instead of writing rules, maybe we annotate data, and then machine learning will learn rules for us, basically. This is kind of, again, depends. Is it better? Is it more cost effective or not? Or we can say, okay, no rules, no features, everything is deep learning. But then we need more data. So it depends on the cost of the unit, basically. I agree that one rule is more expensive than one unit normally, but it can be vice versa, actually. Another thing that we see a lot, so we start from some pilot projects when we don't have volume of data. So even if the customer is ready to share later on some really big data, they kind of say, okay, you first demonstrate that you can do something useful, and then we will give you on production stage everything. So it's basically like we need to learn swim first, and then they will give us water. So this is like the third one is I'm project manager, and to me, longer iterations with deep learning is a little bit worrisome, so to say. Because one thing I normally need to do is talking to the customers, they say, okay, we need that. How soon it will be ready? I need to say. And I cannot say, I don't know. I need to say, okay, in 2 weeks, and I need to do it in 2 weeks. It's okay if it will be half and half, as soon as we can intelligently discuss why it is not working, which features we can add, and how it will be in future. So this is also something that is kind of a concern for me. And another concern, yeah, like, okay, we tried something. Let's say we tried deep learning. What if it doesn't work? Do I need more data, right? Then how much more data I need? So it's, again, on costs. What if it will not be enough again? Yes, so one of my concerns about deep learning is that it kind of makes us to start from scratch, sort of. Well, not always, obviously. Like, I really like what Socher did for sentiment analysis. But again, he didn't start from scratch. He took dependency tree, right, and did it on top of something. So what I see right now, when we say that, okay, let's do it symbolically, let's just look on the letters, I feel a little bit unsure what I will get. Because there is no way for me to say what, except labeling data, to say what I really want from that. To me, it's really like, let's say there is meta-thesaurus. It's huge, huge ontology, vocabulary of diseases. How many times I need to show each disease to neural networks so that it would actually remember it? And I don't have this data, even the corpus, to support each instance in meta-thesaurus. Yes, and so what if the rules already exist? What we see, the recent project is extraction of information from contracts, and they have like 600 fields. And for these 600, they have like 200 pages of documentation, how people would need to do it manually. And it's basically if-then rule for humans. So it's already written in natural language text, basically in English, for normal people, what they need to do. And we need to repeat. And so basically, the number of contracts is finite. So it would be hard to really collect label data for each of these cases. Because that's what we need. We need to create a representative training set. So if we would go with deep learning, we would need to be super careful and like to put a lot of effort going through the rules and probably annotating not just the label, but also the case. Like which sub-rule in this, for this field actually we would need to use. Because here is one more concern. Mistakes needs to look good. Because if customers see mistakes that looks good, they kind of believe, well, yeah, computers are stupid, but they can bring value. But if they see something completely out of place, they really freak out. So in the testing period, mistakes need to look reasonable. So the topic of rules brings back kind of decision trees and explainability problem with deep learning. Because even with decision trees, what I see, when they look on the results, they want to know, okay, why it is like that. Show me examples in training data that actually provoke the system to make this decision. And yeah, in case of decision tree, if customers are smart enough, I can just show them decision tree. Because what we do is essentially we don't do it like a bag of words style. We do relations, so we reduce dimensionality. Instead of words, we use concepts or types of concepts. We use relations, so it brings from bag of words that would be huge. It probably can be like 10, 15 features, maybe 30 features, but it's still something that we can understand like humans looking on this. So basically when going to the next item, when the project is over, if we did a good job creating some resources like dictionaries or some, regular expression set, we can reuse it for the next project. With deep learning, I don't think so. We probably can reuse word vectors, but other than that, I don't see how we can, let's say if we built a super dictionary of company names in Chinese. We can bring this list again to a different Chinese project, but with deep learning, it would be only if it train a separate neural network that specifically recognizes Chinese company names in the text. Okay, so this is something, so to me it feels like this is forgotten tool. How many of you have used this? Yeah, okay, so kind of forgotten, yeah. So for some reason there is so many topic models that, like in Python and anything. So I was using them, having some troubles with installation or something. So Mallet is basically a machine learning library that has been around for a while. It's written in Java, and it has topic models that can recognize phrases. So it's not just words, but it's phrases also. And it can work from command line, and it's very smooth. So this is just some examples of what it brought back. So basically the first was extracted from medical publications, and that's just terms. It grouped it together, so it was like just thousands of publications. It was not a lot. It was also able to combine together all eating disorders from the corpus. And we also did, we tokenized Chinese and printed it such that there are spaces now in the text, so that the tool would be able to tokenize it again, kind of itself, the text. And so this was actually set on radars and nanotechnology, but for some reason it was SVM there, and sometimes then it was able to collect them all together. So Vapnik, as you know, is the author of SVM, and I think it's a little broken, but in Chinese it actually means support vectors. So, I mean, no annotation, and it works very fast. It's you don't even need like you don't need Spark or anything. You can run it on your own machine. So the way we use it is like is for mining, for lexicons. So if we are in a new domain, we don't know at all what we are dealing with, or if we are looking for some key terms in this domain, this is something that is very quick to try and see what is it all about, the document set. Yes, and this is some, so I thought that at the beginning I should do like NLP 101 sort of, but I realized in time that, okay, no, you know everything already. So this is just some things that for some reason kind of escape attention of NLP people. So one thing is RDF, right? Sana is actually implemented as a neural network. I know, I wanted to say it, yeah. So RDF is something that you can look at, and there is a whole conference going on in the Valley right now. So some people say that it's old and dead, but now with NoSQL databases and graph databases, I think it really will come back, basically because it allows doing inference on top of the graph. So not just analyze graph as the network, like to find the shortest path, so some clicks, but actually to look on the graph as semantic data and do inference on top of it. So like a combined relation and create a new relation on top of them. So speaking about graphs, well, I guess a word that everybody knows, just let's make sure that nobody forgets Wikidata, DBpedia, and so on. So again, it's very easy to extract lexicons from there. And just use this traditional NLP, and it will give at least POC very quickly. And yes, so Sena is super monster, like it does all NLP from scratch with a single model. It's actually based on neural networks. I put it here just because it was done in 2011. So neural networks were not that hot at that time. Like it wasn't even called deep learning, I think. It was just neural networks. And yeah, I really don't want this tool to be forgotten. So this is if how many of you never used Sena? Okay, so yeah, worth trying. Especially if you use NLTK and unsatisfied with syntactic parsing and the absence of semantics there. So Sena is kind of something that you can try it on top. And okay, so the last tool, which is I guess missing from this list, Apache Solr. Again, so it's a little bit not NLP, but what is possible to do if you index fragments or if you index sentences, you can actually index named entities in the sentences or relations in the sentences, and then you can write queries in Solr language rather than creating your own well, sophisticated regex 2.0 kind of stuff. So it's already enough to start with querying and see what you get. So it's again like a tool for exploring. So to me, like first things that can be tried is LDE. So that when you get approximately the key terms, and then Solr, so that okay, do you really understand what we are talking about? And it can be done like really in 1 hour. So just to estimate, should we take this project? Yes, and basically the last thing I wanted to say is I'm really looking forward to deep learning evolving and being able to take in knowledge graphs, and so that this all ontology and collected knowledge would be used for something. And deep learning as a super flexible tool, super good for generalization, would be able to catch up with this as well. And would be able to tell why something is correct. So thank you.
Let's repeat the questions for the recording. We'll have some questions.
Okay, sure.
So how do you get the knowledge graph into the deep learning?
That's, I don't know, it's an open question. I really want, I'm not an active researcher in deep learning. I'm more like, if there is only paper and no tool, I will let it go for now. I'm only playing with tools, which is available.
Let's repeat the question.
Oh, okay. Do I need a mic? No, okay. So the question was how to put knowledge graphs, knowledge bases into deep learning. So the answer is I don't know, but I really want it to happen.
Yeah,
can add actually it's an open. It's actually there's a lot of research going on into that, and there are several solutions already. Possible solutions are incorporating the constraints in the knowledge graph into the loss functions. Other approaches use actually, let's put it this way, learn a way of representing each node and each relationship between the knowledge graph in a way that's similar to vector-based, where you learn like vectors for nodes or vectors for relationships, or also other higher level structures like metrics or tensors for relations. So it's an important research field. You can look into, for example, Google Knowledge Vault paper, and also there is like a nice paper from Maximilian Nickel, which covers the state of the art on relational learning.
What's the paper from Google?
From Maximilian Nickel, I don't remember exactly the title. That'd be fine.
Other questions?
Yeah, I'll keep asking questions.
Sure. So I just ask. So because we are recording, and Tatiana has the only mic which records. So if you want to add something, I'll ask you to stand next to the speaker, and then she will pick up the song.
Well, I can pass another mic. Oh, it doesn't have. Oh, okay.
So for like when you're going through PubMed, how deep into the articles did you go? Did you just do the summary, conclusions kind of thing? I mean, often the deep part of the article, even the researchers don't understand.
Well, okay, so we definitely go through abstract, like deeply into abstract, because abstracts are always available and the rest is maybe. But then we go through the whole publication as well. So we basically create it for everything, create representation for everything. So it's good enough to power the search like really well. So if they need information, so we power it like with Solr. We put relations into Solr, and so that works like really neatly. If you say that how recall, well, it can be this and that. So there's no magic. It's like if it's something that we never saw in training data, because we still train relations. The only thing that when we train relations, we say that we use two layers of representations. So we use basic relations. It's similar to semantic role labeling, like Sena does, but it goes into every word basically. So it's a standard set of relations, similar to thematic roles or VerbNet, but expanded with value or manner so that everything is connected. So this is a basic representation. Customers normally do not care if it is an agent or theme, it's just some boring stuff. What they care is something like works for treats between drug and patient. So these domain-specific relations, we learn them on top of basic representation. So basically, we do universal layer, which we could use tree bank, we could use all kinds of annotated data. We did the more or less robust this basic layer, and it saves us some effort on creating high-level relations because we don't need to annotate again from scratch. And the amount of annotation we need is smaller because we already have the basic blocks.
Can you provide any examples of the scale or performance of Mallet ODA? What kind of size corpus you used it with?
Okay, so the scale and performance of LDA. I personally ran it on quite small side, so it was all abstracts of 10 years psychiatry publications on PubMed. So it was tens, thousands of abstracts. So it was a pretty small set. It worked like in minutes. So I wouldn't be even able to drink some coffee. We also did with Chinese, but with tokenized, so basically LDA doesn't care, it's just symbols. And then it probably, and we had like, we had full PDFs, and it's like 20,000, but it still was probably lunchtime. So that was the scale. And it's single machine, yeah, so it's not Spark. It's something that you can really quickly estimate.
Sure. I had tried it like maybe 5 years ago with scholarly content of over 1 million articles, and it was taking a long time. I remember I had to switch elsewhere.
I see.
I don't remember exact times, but the benefit, of course, is the fact that you don't get about the words.
Phrases, yes, yes. Many things cannot do it. It just, I was using Mallet a lot with machine learning, and I was actually starting with LDA with some other tools, and then, oh, okay, it actually can do everything already. It was like a surprise to me. And that was another question back there.
Oh, well, so
it's in many parts, but let me just start by asking how much deep learning does Lymba actually use?
So so the question is how much deep learning we use, and little. So we train word vectors, either with Word2Vec or with GLAF recently. So and we use it mostly for similarity between words, because our applications, if we need relations between words, we need them to be typed. So is it a relation or part whole? And Word2Vec doesn't really give it to you. But for similarity, as additional feature, like similarity, cosine similarity between vectors, as additional feature together with all, it was Ted Pedersen, Perl, I believe, tool with a bunch of like worded similarity, like 3 different things based on the place in the hierarchy. So together with these guys, that's what we use. But again, because a lot of things needs to be typed in our things, in our tasks, I would say. We use it only as an additional thing. And another, so similarity and expansion of search queries. It's again kind of similarity or relatedness.
Probably one more question because we need to move to go to the second one.
Okay, I'll go again. So in you had a big list of implementation problems with deep learning approaches. But a lot of those problems seem maybe not solvable, but at least addressable by the kind of human-in-the-loop iterative techniques you talked about as being kind of the mainstay of the things you build. So like, corpus annotation for training. If you build a simple rule-based system with some basic stuff, and you get some examples, and then you build a little net, and then you re-annotate and go back and forth 5 times, you get pretty far pretty quickly. Have you guys tried anything?
Okay, so the question is that my list of concerns towards deep learning can be solved iteratively with human in the loop. So I can tell you like one thing, basically we need to do POC successfully, we need to go to production successfully. After that, most likely we will never see a lot of data because nobody wants to share data with us. So there is probably only one exception. So it was a project for medical diagnosis. So the task was to classify diagnostic questions into more than 2,000 labels. 2,000 questions. So it's basically recognizing paraphrasing. Just kind of for fun, guess how many samples we had for each?
2, 1.
This was it's true. So for some of the data we had just one, and we needed to create for the. And if you had the data from customer, we had 5. So that was our starting point. And basically what we did there was we said that we played a little bit with the labels. So some labels were like really independent, other labels were more like metrics. So we reduced a little bit the amount of them. So it's more like, so in medical it can be disease, let's say, and some question about this disease, and something like the severity, have you been in hospital with this, and so on, so on, so on. And so for different diseases, there are the same questions. So it's like a metric. So we found several matrices like that. And it helped us to say that, OK, we first do big buckets of classifications. And OK, in this, here is the matrix. We need this classification and this classification. So this was something that we needed to do. Because interestingly, even if we would do more data ourselves, when it comes to production, the actual data looked very different from what we annotated. So our annotated data looked, our questions looked very nicely, and as customer marketologists would use it. And that was a show. But the actual students, they just put some crap into the system and expected some suggestions for, like instead of questions, they just give one word, like hospital. What hospital? Like for what disease? Something like that. So coming back to deep learning. Now, so the system has been in production, and so I most likely have enough data to try deep learning. And luckily, it's a SaaS project, so I have the data. Because so far, it was retraining SVM and all these linear regression classifiers. And this is something that I want to try. But it's also, like, now I have the data, and the project is done. I don't have very much motivation to, only my curiosity basically powers that, which is, needs to be shared among other stuff as well. So it's kind of, if the project is done, then why do we need deep learning after that? Thank you.